Hi everyone. One of this week's lessons, we're going to talk about the order of operations, which is a concept that I'm sure many of you are already familiar with. You may have heard the phrase PEMDAS. You may have used the device, please excuse my dear Aunt Sally, to help us remember the meaning of each of these things, but hopefully you have a good understanding of what each letter stands for. So P stands for parentheses, all right? Whatever is inside the parentheses, we want to simplify within the parentheses first. So if we have multiple parentheses, we start inside and we work our way out. If there is multiple terms inside the parentheses, we follow the order of operations within the parentheses as well. Secondly, we have exponents. So in our second step, if there are any terms that have exponents, we want to simplify any terms with exponents. So something like 5 squared, something like 2 to the third power would be one of the first things we want to simplify on in our order of operations. Now, the M and D. M stands for multiplication and D stands for division. There's a reason why it is written the way it is here with M/D and then an arrow pointing to the right. Basically, we want to multiply and divide in order from left to right. So even though you may see division before multiplication, it doesn't matter. I know in PEMDAS sometimes students will think, well, multiplies before division. It doesn't necessarily matter the order of those two things. Whatever comes first from left to right would be where we start to simplify when we look for multiplication and division. After we have simplified all the multiplying and dividing pieces in the expression, we will then either add or subtract whatever terms we have left. So that would be a very similar process. We will add or subtract at the same time from left to right. So again, if subtraction happens to come up before addition as we're going from left to right, we will utilize or complete the subtraction before we would complete the addition. Okay? It doesn't matter, we just have to go in order from left to right. Now, I'm hoping that process, talking about PEMDAS, is very familiar to you. We have parentheses, exponents, multiply and divide, and then adding and subtracting. So we've taken this concept and we've actually tied it together with something else. So if you go ahead and flip the page, on the back side of your order of operations note sheet, we have another concept. So first of all, if I was just to define order of operations as an overarching concept, not necessarily breaking it down into its parts, we would say this is the process of simplifying an expression using a specific order. And in this case, that order could be referred to as PEMDAS. Now, If we were to jump down and look at some of our first order of operations examples, we will see that in number 13 and number 14, we could actually follow this process and begin to simplify using the order of operations. So we're going to start here with number 13, and then we'll come back to the other concept presented in this lesson. So notice we have parentheses. We always want to start inside the innermost parentheses when possible. So I'm going to keep the brackets, and I'm going to start with 7 minus 4 here. 7 minus 4 is 3, and I'm going to keep the exponent on the outside. Now we want to follow that order of operations inside the parentheses as well, so I will take 135 divided by 5, and then I will simplify the exponent. So 3 squared, 3 to the second power is 9. From here, I'm going to multiply within the brackets. 5 times 9 is equal to 45. And if I complete the division here, if you need a calculator, that's fine. You can use that. And you would get 3 as your final answer. Now number 14, you want to treat this as almost two separate parts. We want to simplify the top, and then we're going to simplify the bottom, and then we're going to divide the result that we get in both of those cases. So if we look at number 14, I'm going to focus on the top half of this expression. So I'm going to start with the exponents within the numerator. So that would give us 4 squared. So 4 squared is equivalent to 16. Now I'm going to multiply and divide from left to right as I work through this problem. So 2 times 16 is 32 minus 8 divided by 2, which is 4. And when I take 32 minus 4, the result of the numerator would be 28. Now, on the bottom, I want to start in the parentheses. 5 plus 2 is 7 times 2. 7 times 2 is 14. And 28 divided by 14 will give us a final answer of 2. Now, you will notice in 15 and 16, we get these bars that are in the problem, and they look a little bit similar to parentheses, but you'll notice they are just two straight lines. And those lines indicate the concept of absolute value. Some of you may remember absolute value as being always positive, and that's a good way to remember it, but the reason it is always positive is because it is actually the distance from 0 on a number line. So if I was at positive 5 on the number line, I would be 5 units away. If I was at negative 5 on the number line, I would be 5 units away. So it is always a positive result when we are talking about distance. We don't ever talk about traveling negative miles. So think of it in terms of traveling. We always are traveling in a positive direction or a positive number of miles. So if we start off basic here, we look at number 1, we have the absolute value of negative 13. Well, that would turn into positive 13. The absolute value of 21 will remain positive 21. Now if I look at number 3, I have an absolute value of negative 3, that is positive 3, plus the absolute value of negative 5, that is positive 5. So 3 plus 5 would give us a positive 8 as the result in number 3. Same idea on number 4. 9 plus negative 8, well, that absolute value turns that negative 8 to a positive, so 9 plus 8 is 17. Similar concept in number 5. negative 12 turns positive, 15 stays positive, so 12 plus 15 is 27. Okay. Number 6, 21 minus 17. Now this is inside the absolute value, so you simplify within the absolute value as if they were parentheses. 21 minus 17 is positive 4. The absolute value of positive 4 remains positive 4. Number 7, the absolute value of negative 11 is positive 11 minus the absolute value of negative 5. Again, that would turn to a positive 5. So 11 minus 5 gives us a result of 6. In number 8, absolute value of 4 minus the absolute value of negative 4. Again, it turns positive. Notice though that the minus sign that is in the middle remains a subtraction symbol in the second step. So in this case we have 4 minus 4, which is equal to 0. If you want to take a moment and pause the video here and try the last column on your own, this would be a great spot to do that, and then you could see if you have an understanding. Come back and play the end of the video and double check your work on 9 through 12. Okay, so if you notice in number 9, we have 15 minus 23. That is all within the absolute value, so we're going to simplify inside first. We would get negative 8. At this point, we're going to take the absolute value of that number, and our final answer would be positive 8. For number 10, we have 24 minus, and this negative 15 will turn positive, so we get a final answer of 9. In number 11, we have 28, it will stay 28, minus, that will turn to a positive 26. 28 minus 26 would give us 2. And the last problem on this page, this absolute value of negative 3 will turn to a positive, plus a positive 19 gives us a result of 22. Okay, now looking at the bottom, now that we have reviewed all of these absolute value examples, we notice in number 15 there are absolute value bars, parentheses, there's exponents, so we have to piece it all together to make this workable. So first we want to start within those parentheses. 8 minus 5 would give us 3 to the third power. And now we have all of these exponents that we could take care of. I'm going to bring everything down into the second step so we can take care of all of the exponents at the same time. Remember, you have that calculator feature on your Chromebooks, and it's probably going to be helpful to many of you. If we take 3 to the third power, we get 27, minus 5 squared is 25, minus 4 to the third, which is 64, divided by 3. Okay, now we treat the absolute value just like we did parentheses, and we end up with a negative 39 divided by 3. Well, that absolute value turns that negative 39 to a positive 39. We will complete the division step at this point and then subtract 27 minus 13 to get positive 14. I would ask that you give number 16 a try on your own, and we will talk about number 16 together when we return to class the next day that we meet in person. Good luck, and if you have any questions, as always, please reach out to me if you need any help.